How's this? Can we hear in the back? 1, 2. Good? Okay. Awesome. I see 1 or 2 cameras left. Awesome. Okay, I'll throw this back up at the end. So I'll just introduce myself real quick so that we can get going. I've been doing full stack development for 10 years before it was called that. Like back then, it just meant like I'll do everything and not say no. Apparently there's a name for that now. That was way back when I did a lot of like PHP kind of stuff. But I've been doing full stack with JavaScript since about 2011 with a combo of Node and Angular. My last company was an online language learning company, so we basically had a virtual classroom in the browser, and we were always like iterating that. So this combo worked really well for us. Currently, I'm leading JavaScript development at Stormpath. We have a booth downstairs. Wow, as I turn my head, it's like, hey. Yeah, lead JavaScript at Stormpath. We got a booth downstairs. You should check us out. I'll tell you a little bit about what we do, because that'll give some insight into... Somebody's waving. Okay. Some insight into where all the kind of like meat of this talk comes from. Basically, we're like a cloud identity API, so you can think of us as like a modern cloud-based directory service for storing user data as well as doing authentication services. We're primarily meant to be used with your backend service, but the front end does get involved when you start talking about like user authentication sessions and all that kind of stuff. So a lot of this talk has been informed by my work at Stormpath, helping build out our JavaScript integrations for our product. We got a free plan for developers, so if you're curious about offloading user management, check us out. We've also got a booth downstairs, and we're more than happy to like dig deep and have a good conversation about like how this could be useful. So, high-level overview of the talk. It is a pretty long talk. It comes in at about 45 minutes. I know this is like, I think, an hour and a half, which is a long time. But these are the high points we're going to hit. We're going to talk about what the security concerns are for modern web applications, which inevitably means that we're going to talk about cookies. So we're going to talk about how to do those the right way, because cookies have gotten a bad rap, but I kind of want to untangle that a bit, because I feel like it's not always warranted. We're going to talk about the problems with session IDs and why JWTs are becoming a thing. And at the end, I'm going to show you kind of just a few slides from an example application that we have on GitHub that you can check out. So web apps. What do we mean when we're talking about web apps? Well, these days, it usually means we're talking to a back-end API that's JSON. So we've got some kind of like rich client typically running in an HTML5 environment, and it's getting its data from a JSON API. And the thing that we're most familiar with is this new idea of a single-page app, like Angularjs. I recently added React to this because it's for real now, I guess. And oftentimes you'll see these like native desktop solutions where it's like, oh, you know, code HTML5, it's turned into a native desktop app. Really, that's just a WebKit instance, so you're still dealing with browsers. And same with a lot of these like hybrid mobile app things like PhoneGap. You're really just running in like a web view. So a lot of the like security concerns still apply. And those concerns are, you know, basic but very like, there's lots of nuance to them. Like at the end of the day, we're trying to secure user credentials and server endpoints. You know, when a user presents their username and password, we don't want them to have to do that every single time our front end needs to make a request to the back end. Similarly, because we're talking about web applications, we have to talk about preventing malicious code from running on the client. This is like, you know, XSS attacks, JavaScript from strange places that shouldn't be running in our application. And something that you probably run into if you're working on front-end applications is, you know, informing the front end what it can and can't do, like what views the user can't see and so forth. It gets kind of complicated when you can't assume that every action the user does in the browser is going to trigger a request to the backend. You know, they might navigate through a few views without actually having to fetch information from the server. So these are kind of like the security concerns that we're dealing with. And after I kind of revisit how we've been doing this traditionally, we'll see how JWTs are actually trying to address some of these concerns. Okay, So the traditional solution that we're all used to is this notion of a session identifier. Every web framework out there has some kind of session mechanism. And really all we're doing is accepting the username and password, creating a session, which is literally just like an opaque ID that means, okay, somebody gave me a username and password, so I'm going to trust this person for a while. I'm going to trust their client. I'm going to trust their browser. So, using awesome flowcharts, this is something we've all seen before, right? This is sort of like user authentication 101. There's going to be a login form. You're going to post credentials. You're going to get back this random ID thing and a cookie. And so long as the cookie goes back to the server on the next request to get my profile page or what have you, then the server is happy. It believes me. This is okay if you protect your cookies. We're going to talk a lot about cookies in this talk. And it's okay if you're like fine with this like layering of like a session ID basically points to a user identity. A few layers of like database relations there. And we probably all use a framework like Apache Shiro or Spring Security to like assert some rules and roles around that user, which really is just means you're pulling all this information from the database on every request and doing some conditional logic to allow the request or not. So, on the surface, there's not really much wrong with it, but there are some problems that people are trying to address, and this is where JWTs are coming in. The biggest problem is that these IDs are pretty opaque. Like, they're pretty meaningless. They're really just pointers to other user information in your database. So if you're operating at high scale, this becomes a problem super quick if you're hitting your user table on every single request. We've developed like caching layers, caching frameworks to deal with this problem. That's a problem. And because these things are totally opaque, we really can't use them to interop with other services. If you're working in like a microservice environment, we've got many different processes all trying to like deal with user data. This becomes annoying super fast because you may end up in a situation where 3 different microservices are involved with fulfilling one response, and they're all hitting the user database, and it gets crazy super fast. JWTs can help with this. We're gonna revisit this concept when we actually dive into JWTs. But we're going to talk about cookies first. I've experimented with where in the talk the cookie part goes, and everybody always wants to talk about cookies, so I put it early on. So cookies are the right way. There is actually a right way. And what we're really dealing with when we deal with cookie security is 3 really common but actually easily solvable attacks. The one that I think we're the most familiar with is a man-in-the-middle attack, where somebody is listening on the wire. This was the hack that happened many years ago now, where like malicious people would go to a Wi-Fi cafe, just inspect all the traffic and steal your Facebook cookies, and then post crazy shit on your timeline as you. Does anybody remember that one? That one was super fun. So you want to prevent that from happening. And the easiest solution, which is easier now that we've just got like free utility-based computing power everywhere, is just to use HTTPS, TLS everywhere. Like have a really good secure connection between browsers and mobile clients and your server. That's really the best thing to do. But there's this other little caveat that actually impacts cookies, which is you want to set the secure flag. So when your server is sending cookie responses down to a web browser, this doesn't always work for mobile clients. You need to look into this. But web browsers respect this thing called a secure flag, which means if this cookie comes in with this flag and the user gets redirected through some endpoint on your server that's actually not on HTTPS, the browser's not going to send that cookie. This is something that happens a lot because, like, I'm sure we've all done this, where we put our login system and the secure endpoints on HTTPS, but everything else is like, oh, whatever, that doesn't matter, so we just leave it like not secured. But if the user gets redirected through those endpoints and the cookie goes over the wire, it's the same problem. So this is one way to tell the browser, like, if you're on a non-secure, just don't even send the cookie. It's a quick way to make sure that cookies always going over an encrypted connection. Okay, that's the easy one. You just use secure channels. But cross-site scripting is the harder one. This is the one that I think we're the most familiar with because everybody like tries to scare each other with it because it is actually a real problem. Basically, this is what happens when JavaScript code that's not yours gets injected on your site. And there's a handful of ways that this can be done. I'm actually going to refer you guys to the OWASP document on this if you haven't read it already. It's basically like if there's some way that untrusted code can get rendered on your website, this is how it happens. I'm going to show a quick demo of that. But this can be used to steal your cookies. This is the demo I'm going to show. This is actually like a modified version of Google's security guidelines. They're trying to like beat OWASP out of Google search rankings for these kinds of things, apparently. So they've got their own version of this with some really cool examples. And I'm stealing and modifying their examples. So when people talk about XSS, the common demo they show is either like a demo like user forum or like a chat app. And God, it's really hard to see on the screen. So in this like naive application, we've implemented a little chat box, and what's happening is we're kind of just like arbitrarily taking whatever is in that box and trying to stuff it into the DOM, stuff it into the web page, which is super bad. I mean, like that's basically the number one thing you never want to do to prevent XSS from happening. And so the example I'm showing here is like if your website is allowing me to do this, I can put in this malicious image tag with an on-error handler that's going to get invoked when this thing tries to get inserted in the page. And there's actually a DOM API for reading cookies, document.cookie. So I can basically just like read out all your cookies and get your session IDs. So, while XSS is bad, it's super bad because it can also be used to steal your cookies. And even further, if I were to actually like put some more malicious code in there, I can actually not only read that document cookie, but make an arbitrary request to my like super awesome database where I keep stolen cookies. And the browser is just going to comply when it makes this GET request. I've like now got all your cookies. It's like super crazy. So solutions: escape your content. Basically, never do what this demo app lets you do. Like, never trust input that is being given to you. Always escape it. Never try to like evaluate it as actual HTML code or JavaScript. This is super easy stuff to solve. Every framework has got, basically every templating engine does this for you automatically, but I encourage you to go read the docs on whatever you're using just to assert that that's true. And same on the client, like most JavaScript client frameworks like Angular, I'm not sure about React actually, but they've internally like architected everything so it's actually like not possible there's like straight up eval code like this from untrusted sources. So those are the content things you can do. But as I was talking before, there's some flags we can use on cookies to help us out. We talked about the secure cookie flag, but there's also this really awesome one called HTTP only. And this is like my favorite web browser feature that actually works across all the browsers. If you set this flag, the JavaScript environment actually can't read your cookies. So in that hack earlier where I was saying document.cookie to read the cookies, it's not going to work for this. It's just going to return an empty string if your cookies are HTTP only. So this is, again, a very simple thing you can do. Just throw this flag on your cookies, and then they can't be accessible to JavaScript. So you've just nullified XSS attacks like right off the bat. And again, the OWASP guide, they've got really, really great resources around all of this. Okay, so everyone knows XSS, but how many people know about CSRF? Well, that's actually good at raising a hand. Sometimes I get like one, which scares the heck out of me. So this is another cookie stealing attack. So you can read the OWASP stuff. The OWASP stuff is super verbose on this. But the way I summarize it is it's exploiting the fact that HTML tags don't follow the same origin policy when making GET requests. The same origin policy is something that they've implemented in the browser to help kind of mitigate some like cross-domain scripting attacks. But it doesn't apply to basic HTML markup like image tags. So what happens in this situation is there's an attacker who's running a website. It's not your website, it's theirs. They have control over the site. And they've managed to get the user to visit it, clicking on an ad or whatever. However they get there, it doesn't matter. The fact is, the attacker controls some sites they can put their own markup on. And what they do is they put in something like an image tag that makes a reference to an endpoint on your server. And the colloquial example here is like some crazy endpoint that I hope nobody's ever actually done, which is like a GET request endpoint where you can supply parameters saying like who you want to transfer money to. So I really hope it's never been done, but it's a good example. But the idea is like, okay, there's some endpoint that you make a GET request to it, and it's modifying some sensitive state on the server. Well, what happens in this situation is the browser complies with this kind of like naive thing of wanting to do the right thing and send cookies to the right places. So it sees that the request is going to your site, this trusted site, and it happily sends along the cookies for that site. So if the user's like already logged in and has that trusted session based on that session ID, that request goes through. The server is not paying attention to where this request comes from. So simply by just putting a malicious image tag on a site, the attacker has modified state on your server. And this is like super scary. Now, there's a handful of solutions for this one, because this one's actually a little harder to solve. But the solution is pretty obvious once you see it. If you look at the reading, you'll see two main things: the synchronizer token pattern and the double submit cookie pattern. Both of them are basically like leveraging the idea we're going to create another token that's sort of sent out of bounds of the normal cookie submission thing the browser does. So you can compare to be like, hey, where is this actually coming from? I'm not going to talk about the synchronizer token pattern because it only works with form-based apps. It doesn't work with like these rich front-end applications. And if you're using any kind of like a rich form system in your web framework, it's probably doing this for you already, but you should look to see if that's true. So I'm going to talk about the double submit cookie, and I'm also going to mention at the end the origin header check. It's not something you should rely on, but it's a little like nice to have for extra measure. So the way this double submit cookie thing works is you're going to give the client two cookies, not only your session ID and a strong random value, but you're going to have the client do something that triggers that same origin policy so that the browser kicks in its security model and says, wait a minute, like this request is to a different domain. I'm not going to let that happen. And the easiest way to do that, and you can do this with JavaScript, is to set a custom header. So let's look at this as a flowchart, just because I find that easier, although it might not be super easy from back there. We're basically revisiting now that login flow that we saw very early on. But in addition to a session ID, we're also setting a cookie called XSRF token. You'll see it called a million different things. XSRF token has a convenience for Angular. We'll talk about that a bit later. So you set these two cookies down on the login response. Then on subsequent requests, where your rich client is talking to your backend, it's going to create a custom header called x-xsrf token. Again, this is just convention. There's no actual like protocols around this. And so setting that header is going to kick in that browser security model. And so this is not going to work from a malicious domain. So your server can just do this really simple thing, which is saying like, hey, that cookie that I sent down in a token, do I also see it coming in a custom header? If so, I can assume that this is JavaScript that's running on my domain, so not some random like GET request from another domain. If the attacker does try to do this, these are actually red. There's like red all over this thing. This is like the attacker situation. So in the first example here, they're trying their like rando image request thing, and the server is going to respond and say, hey, I don't see that header with the token. I only see it as a cookie, so I'm just going to straight up reject this. However, if the browser, if they somehow got like JavaScript running on some other website, same problem. It's not going to happen because now the browser is going to kick in and say, hey, wait a minute, you're trying to add this custom HTTP header to this request going to this other domain. I'm not going to allow that to happen. Now, caveat. I'm sure we've all had the experience of like having an admin interface on one domain and an API on another domain. And we run into exactly these errors because they're on different domains. And so we Google around, and people are like, oh, just add these to like your server responses. Well, no, don't do that. Like, it's gonna effectively disable the same origin policy. There is this whole CORS thing that allows your server to specifically tell clients which domains can talk to each other, but putting a wildcard in there effectively disables the security that you'd be implementing with the CSRF token pattern. So don't do that. Be more explicit about which domains can talk to each other. Okay. A few other quick things to mention in this space. The browser does send an origin header, which can't be modified by JavaScript. So you can also use that as sort of like a second measure to be like, hey, is this request coming from JavaScript on my domain? But it can be modified by malicious proxies. So again, there's another reason to use HTTPS like everywhere you can. Okay. So that's sort of like I can't get through any part of this talk without laying out all those like cookie disclosures, because as we get into talking about token authentication, we're going to be talking about how to store tokens in the browser, and we're going to be talking about how to do that securely with cookies, because some of the other alternatives are actually not so secure. Now, token authentication involves a lot of things. As I mentioned, it involves cookies, but it also involves some terminology. It overlaps with OAuth a bit, sort of by accident, not explicitly. So I'm going to kind of be covering this like amorphous solution that JWTs are, and hopefully bring us to like a useful understanding. Okay, all you need to know, right? So authentication is proving who you are. That's the login attempt that we saw earlier. This is where you're presenting some form of credentials in exchange for a token. You know, in these examples, the tokens are username and password, but nowadays with lots of API services, we're also seeing credentials be things like an API key pair. You know, this is a pretty common thing we're used to now. You're using some kind of service, you've got your developer account, they issue keys associated with the account. Those keys are used to authenticate your request or your application against it. The token is a way of persisting that proof. So these structured tokens that we're going to be talking about, they're basically replacing that session identifier. In the workflow, architecturally, it's kind of the same as a session identifier, meaning like it's this little thing you get back after you authenticate, but it's more structured, and that we're going to talk about the benefits of that. It's not just a random ID. JWTs are a token format. So JWTs are often used in OAuth as the access and refresh token format. OAuth 2 doesn't actually prescribe JWTs. That's a common thing I run into. The OAuth workflows talk about tokens, but like most RFCs, that's one of those implementation details. It's up to you to figure out how to do that part. So that's where JWT came in. It was like, all right, tokens, we need some way to structure these things. That's where the connection is. And lastly, they're fun. So let's just get on with it. But in the wild, they really just look like another ugly ID string, right? How does this look any different from a session identifier? Well, you got to decode it is the answer. So when you see a JWT, it's actually a 3-part string separated by 2 periods. There's a header, a body, and a cryptographic signature. These are all base 64 URL encoded, which is slightly different than just regular base URL and 64 encoding. It's different. Okay, so blah, blah, blah. We ran it through our decoder thingy. And now we see the fun parts. These are the JSON parts of the web token. Header, body, and claims. The header is basically telling you, it's sort of like envelope information for a message. It's telling you the type of the message, the format, which is JWT. And in this particular case, it's specifying the algorithm that was used to create the cryptographic signature. You can also compress and encrypt JWTs. So there's a few other standard by the RFC fields for that information. So the header just sort of saying here's what this thing, here's how it's encoded, encrypted, compressed, whatever. The claims body is where things get super interesting. This is the structured part. The JWT spec declares a bunch of recommended fields. You know, it's a spec. But I'm going to cover these four because these are the ones you're going to run into the most. So they say that you should declare who issued the token. This is some kind of URI to an application that issued it. You know, in this example, it's trusttheapp.com. But imagine you've got like internally a handful of applications, maybe on different domains. You could use the different domains, subdomains, whatever here. You have to declare when the token expires, because one of the benefits we're going to see about JWTs is that cryptographic signing actually allows us to kind of just do stateless authentication checks without going back to our database. So you have to make a decision about when this thing expires, because otherwise it'd be implicit trust forever. So you declare that in the token itself. You also identify the subject of the token, basically who is the person, who authenticated. Typically, this is just some kind of like identifier in your database that you can use to go fetch more information about the user. And then scope. So this is where we're going to see another overlap with JWT and OAuth. So OAuth is an authorization framework, which is basically talking about access control. So they talk a lot about scopes. In OAuth, the idea is that like you request access, you request scope to some resources, and then you're granted that scope. Well, in JWTs, you'll often see scope being persisted in a token because, again, as we'll see, like this gives us a stateless, verifiable way to see what the user has access to. This is basically a permission list. So in some systems, this will also be like kind of a permission earn or URI, you know, one of those crazy like colon delimited strings. All right. So issuing these things, who issues them? Well, it's basically your server. And this happens at the time that the user is presenting their hard credentials, the password or API keys. And then you create these tokens. You basically create those JSON objects, and then you pack it all together in that format. There's a million libraries for these things. We sponsor one called JWTK, which you've probably run into if you've done this in Java. So because they're signed by your server, you need to make sure that key is private. You know, you're signing these things, you're putting them out into the world. You want to verify that they came from you when you see them again in the future. The client's going to store these tokens and use them to authenticate requests. So again, the browser is kind of a hostile environment for storing secure information. We're going to talk a bit more about how that should be done. On the verifying side, so you know, we've issued these things, the client is storing them securely, they're not getting stolen, everything's great. So the client's going to use these to authenticate requests. So you've got this rich client in the browser, it's requesting JSON data from your API, it's presenting these credentials as a way to authenticate. And because we've got a signature and expiration time, this is like, on the first gut reaction is like, oh man, it's this like holy nirvana of like stateless authentication, right? Like I don't have to go touch a database service to know like who this user is. And because of that scope value, I can also make local authorization decisions. So it's like I can do this really quick stuff in my application. But that thought will always last like maybe about 10 seconds before you realize like, well, wait a minute, like how do I revoke that stateless authentication? We're gonna talk a bit about that as well. That's again going to be another overlap with JWTs and some OAuth ideas. But let's talk about storing for a second. So storing these in local storage in the browser, I'm just going to flat out say is not secure, and it's because of that XSS vulnerability. When you start looking at JWT example code and libraries out there, pretty much everybody's putting these things in local storage, but I'm just throwing this huge advisory out here that like you basically run into the same problem with cookies where because it's accessible from the JavaScript environment, you open yourself up to an XSS attack. So the easiest way to prevent that is just to not use local storage. Cookies, if you implement CSRF protection and those flags that I was talking about, is actually much more secure because the JavaScript environment just can't even touch it. There's one more benefit to storing the cookies in, storing the JWTs in cookies, which is that the browser automatically supplies those things. Obviously, that's the CSRF problem, but if you mitigate it, there's actually some really good use cases for using cookies here. Okay. JWT plus OAuth 2. This is where it can get super, super confusing, and it's really annoying. So OAuth 2, which is an RFC, it's an authorization framework, and a great thing to read after lunch, and you're at your desk, and you're like almost ready to doze off, and you're like, just start reading this, and like you'll get the rest of the way. But if you do manage to make it, I think maybe 3/4 of the way through, it defines what they call the resource owner password credentials grant, which is really just a fancy way of them saying like, okay, yeah, people want to present usernames and passwords and get tokens back. Like this whole framework just for that, right? I mean, I shouldn't bash on it. There's actually some useful ideas in there, but there's this one thing in there which is actually pretty useful. So when you get in and start reading about this and all the other token stuff, they basically prescribe this idea of an access token and a refresh token. And this is their solution to this stateless trust trade-off. And so the idea is that the access token should be like, yes, stateless verifiable, but for a shorter period of time. Because if that token gets compromised, it gets stolen through an XSS attack, man in the middle, whatever, you don't want that scope of access to be valid for a super long time. The idea then is that you have this refresh token, which can be used to get more access tokens. And at the time when a refresh token is presented for, hey, give me another access token, that's when you'll do a little more heavy lifting. You'll go back to the database and be like, hey, has this token been revoked? Is this user account still valid? Has their scope been revoked? That's the time at which you can do sort of like those heavier things. So I've been trying to find like really good ways to summarize this, and this is what I got so far. Access tokens and refresh tokens are designed to give you control over the implicit trust trade-off that is made with stateless tokens, because it feels a little like exciting and insecure at the same time. Like, great, save this off, but wait a minute, it's implicitly trusted until it expires. So there's a few ways you can think about it if you're gonna adopt this scheme. The refresh token is basically setting the maximum lifetime of the authenticated context. It's like, of this scope that I have granted, it's definitely going to end at some point in time, which is the expiration time of the refresh token. The authentication token sets the maximum window in which you can do stateless authentication before it expires. So this is sort of like that window of like, okay, how long should this token be valid for without hitting my database servers, but short enough that if it gets compromised, I feel like it's not a big deal. The whole authentication context is removed by simply revoking the refresh token. Now, I find this easier by example. So there's two examples here on like opposite ends of the spectrum. So if you're implementing some like super secure banking application where you want to force users out often, you know, we've all had that experience, like being logged into your bank app, and like even though you're using it, you get like forced logged out. This is that example. So in this situation, you would set your refresh token at 30 minutes, which means no matter what the user is doing, that session is just going to end after 30 minutes. And the access token is only going to be valid for a minute. So again, you know, it's like it begs the question, like, how useful is this? Because if the user is only interacting with the app maybe once every 3 or 5 minutes, you know, I'm still doing a whole database round trip. But like this is what this solution looks like if you're going to try to implement it. The other end of the spectrum is like your mobile social app that just doesn't care about security, and the user should be logged in forever, basically. So in this situation, you're going to set the refresh token to basically be valid for longer than you're going to have a phone, and set the access token to something really short, like maybe an hour. So it's sort of this like loose, passive way to be like, hey, if we need to kick off this user, we can kick them off like within an hour. It's like that kind of a thing. Again, it's like this all just really gives you a way to kind of scale how you want to deal with this problem in your architecture, which is like quick request authentication versus some kind of longer round trip to more heavy services. All right, demonstrations. So this project is up on GitHub. This is a combination of a Node.js backend and an Angular frontend that shows some of these concepts at play, which is like logging in, getting tokens back, them being stored in cookies, them being sent up to the server. Behind the scenes, it's using Stormpath as the cloud database, but the concepts are all there in the source code. You don't have to use Stormpath to actually like grok what's going on here. I'm not doing a live demo because that's always crazy. So here's a screenshot of the login form. Now what happens here is pretty straightforward stuff. We're posting to the login endpoint on our local server, supplying the username and password. Behind the scenes, the OAuth provider is actually Stormpath, but the concept is the same. You're doing that OAuth flow to get back an access and refresh token. And so the server is going to send these down in those HTTP-only cookies. There's no secure flag because this is a local host demo. That's happening. And we're setting the expiration times to the expirations of those individual tokens. So you'll see that the access token actually has a much shorter time than the refresh token. So because they're now in the browser, we've got to do all that CSRF stuff I talked about earlier. But the really cool thing is that when I make GET requests to protected endpoints, the browser is going to automatically supply those cookies to the backend server. And now the backend server can basically go through this authentication flow that deals with access and refresh tokens. So the first thing you're going to do is say, like, is there an access token? If so, I'm going to check, hey, was it signed by me? Was it signed by my authentication service? And has it expired yet? If both those checks are true, great. This is our quick stateless check. We allow the request to go through. If not, we're going to try to get a new access token with the refresh token that was presented. If that works, we just transparently send down the new access token on our new set cookie response. Otherwise, if that refresh token has been revoked, the session's over. We're going to delete the cookies and just be done with this. So you'll use like a 401 status response, and then your front end can be like, okay, anytime I see a 401 or response from the server, I know that the session has ended, bounce the user back to the login page. So the cookies are nice because you can just use these really simple HTTP mechanics in your front end to know if the user is logged in or not, and if they need to be redirected back to a login page. Okay, it's only been 37 minutes. I know we got like an hour and 15 minutes, but this is like the recap of the content here. Your cookies need to be secured. CSRF is the biggest thing. If you haven't checked your app for that, go check it like now because it's a really big concern. JWTs are an improvement over the opaque session identifier, but this whole stateless authentication thing brings in some interesting concerns. The access token and refresh token paradigm in OAuth tries to address some of this stuff. Even though the spec puts you to sleep, there are some good ideas in there. So I'd recommend checking it out, or even just reading some blog posts that try to like summarize it. There's some really great reads out there that talk about like what's great and what not so great about it. So with that, the Cookie Monster, thank you. And if you're curious about Stormpath, come check us out downstairs. We can talk to you about how our service actually kind of like encapsulates a lot of these concerns for you. With that, we got lots of time. So if there's questions, I would love them. Yeah. Yeah, so the question is, can the server know if a token has been hijacked? And the answer is no. This is like the inherent problem, not only with tokens, but just with like using session identifiers in a cookie. You have like no way of knowing that it got hijacked. So that's where like having things like CSRF protection comes in. You might want to implement other heuristics like IP-based kind of stuff, like, hey, if all of a sudden I see requests coming from different locations, that might be a flag. That's like an interesting use case for some cool security software out there that can like detect those kinds of things for you. Talking a little bit more about that, if you do have some software that can indicate like, weird request context from a user and you want to revoke the tokens, the refresh token scheme, you revoke the refresh token, but it still leaves that access token kind of hanging out there in the air. So if you're security conscious, you just want to make that access token a short lifetime. Yeah. Oh, I'm sorry. Yeah, let me put that back on. So, cool. Question up front here. to prevent them from decoding, yeah, actually you can encrypt JWTs as well. So the actual content is opaque unless decrypted with the proper key. Yeah. I do think there might be an OAuth flow, actually not an OAuth flow, but there's some implementations, yeah, where the client, the question was like, can the client not store the refresh token and be challenged for it? I have seen architectures where people do that, and they'll do something like store the refresh token in some other secure location where you have to cross like an API boundary. I have seen architectures like that, yeah. There's not really like any kind of a specification or much of a protocol around this. It's just like weird semantics you'll have to implement in your API with some kind of like error response you could inspect or something like that. So, in the back. Yeah, so the question is, if you have a separate service that sends out the tokens, do you have to have a separate service to authenticate them? Is that right? Oh, I see. If you have to call that service. Not necessarily. And this is where it gets super interesting, because you're just signing with this key. And I've actually done this in a few situations. You have one service that issues them and another service that verifies them. But as long as they both have access to that private key, that's really all they need. Because the verification side is just basic crypto. And even on the signing side, it's basic crypto plus like access to your authentication and user context database that can tell you the things you need to know. So, yeah. Yeah, so the question is, like, in the client, in the single-page app, how can you access and read the token? If you do my recommended cookie approach of preventing it from JavaScript, yes, that does introduce the problem where you can't inspect the token and look at things like the scope, which is really actually useful. So that is one argument for using local storage and exposing it to JavaScript. My solution, though, is actually creating a third cookie called like scope or something like that, or even just token, where you can store the claims body of the token in a cookie that's accessible by JavaScript, but protecting the actual signed token that you use for authentication in like a separate isolated cookie. So, there was a question. That was your question. Yeah, that question comes up a lot, and this is why you sort of see all the examples out there. Just throw it in local storage and start decoding the client side, but that just feels super gross to me because I'm really afraid of XSS attacks. So my proposed solution is, yeah, like if there's anything in the token you need, just set it in another cookie and let that cookie be accessible by JavaScript, but always protect the signed token from JavaScript, because that's kind of like the keys to the castle. Like the claims are just information about the context; they're not actually giving you access to anything. And that's the question is like, that recommendation I'm saying of taking the information out of the token, you put it in a cookie or local storage, it's up to you. In that situation, local storage is usually easier. So, but servers can also set cookies, so it's like one less thing your client has to do. It just sort of like however you feel like doing it. So cool. I feel like there was another question in the back, maybe not. Awesome, guys. Oh, yeah.
More of a comment, but I've read that there have been past security vulnerabilities with JWT, and needing to use certain client implementations, certain version levels. I'm not sure, but
yeah, questions about past vulnerabilities in JWT client libraries implementations. Yeah, like like any new set of libraries that comes out, a lot of JWT client libraries had like really simple, silly flaws where like if you omitted the type header, it would assume like, oh, I don't need to check the cryptographic signature. Like it was just little logical decisions in the client implementation that would allow JWT to go through even if it was expired or not signed correctly. There were some other issues around like using RSA key pairs the right way. So yes, there were some concerns. To my knowledge, they've all been fixed. So what I would encourage you to do is that if you're looking at a JWT implementation, read the tests, just like kind of sanity check it, because a lot of these libraries are new. So, yeah. Yeah. Question was for my awesome Twitter handle. I missed the Twitter land grab and refused to cave and pick a new name, so I underscored it. Cool. Other questions? Feel free to come grab me. I'll hang here for a bit, and then we've also got a table downstairs. I love talking about this stuff, so I love answering questions. Thanks, guys.